Okay. Hi, folks. Thanks a lot for taking the time to attend this session. I know it's firstly a Thursday. A lot of us are waiting for the party tonight. In some cases, waiting to go home as well. So safe travels if you're taking a flight today or tomorrow. Again, appreciate you taking the time to attend this session on software-defined networking with Windows Server and System Center SP1. Hopefully a lot of us got a chance to attend the keynote and a bunch of other sessions in the lead up to this one, and you have a good sense of the depth and breadth that we brought to market with Windows Server 2012 and System Center 2012. So this session will kind of click down on the networking aspects as enabled by the magic of software and how we actually deliver some great capabilities to help you move further in this process of transforming your data centers. So hopefully, this should be an exciting session to talk about software-defined networking as well. Before I actually kick off, I just wanted to introduce myself and the rest of the presenters here. My name is Anant Sundaram, and I'm part of the Windows Server and System Center product marketing team. So I certainly have interest in software-defined networking and also System Center and the breadth of a portfolio there. And I am certainly looking forward to engage with a lot of you folks over the coming months as we talk more and more about our software-defined networking solutions, and I'm hoping to sort of get some feedback from you as we go along as well. We have CJ Williams here, who is our Windows networking SME, if you will. He's part of the core team that builds a foundation of our networking technologies in Windows Client and Windows Server. We've got Dhananjay Mahajan, who is going to bring in the partner perspective. Right? We'll talk about SDN as a solution, so we absolutely think that our partner ecosystem has a significant role to sort of cover the end-to-end scenario and the solution that we'll talk about. So hopefully, between the three of us, we'll have a good way to engage with you folks. We'll hopefully also leave some time for Q&A at the end, and feel free to walk to us after the session so that we can have some more detailed discussions. Okay? With that said, what are some of the key goals of this session? So the first important thing is, all of us are IT pros, and you want to understand why should you care about SDN, right? So we'll certainly spend some time on that. Next is we'll talk about Microsoft's approach to SDN, including our key tenets or principles, if you will, and how we actually got to this point with our technologies and solutions in this area. And then we'll unpack what are the various piece parts or components of our SDN solution, including certainly all of the breadth of technologies that make it up through Windows Server and System Center, but then also talk about how our partners are helping us complete our solutions as it relates to private and hybrid cloud computing. And then, if we do a good job, hopefully you'll walk away with three things. The first is you've got a bunch of great technology bits in the box today, right, with Windows Server and System Center, and hopefully we'll sort of, convince you that you can kick the tires today on SDN. A more important point is all of us in the room have a significant opportunity to influence the future of networking as it works in your organization. I'm guessing, knowing the MMS audience, a lot of us are server administrators or folks who actually have responsibilities for server management and data center compute management, SLAs, and the like. But then you will see that you've got a great opportunity to shape how to holistically transform networking as we know it and help your company rethink networking. You will see that, we've actually done a lot of cross-learnings and cross-pollination between our work with our global online services like Windows Azure and brought it to our SDN solutions with Server and System Center, and we'll continue to do that. And then the third thing is, we want to make SDN approachable to everybody, right? We don't want to make it seem like, hey, I need a PhD in networking to actually use some of this technology, right? So we at the same time, we want to make sure that we involve our partners, and we work broadly with other industry participants as well to make sure that you get what you need in terms of the breadth and choice of networking solutions. So hopefully that sounds interesting. So then let me start, with the same frame that Brad had used, right, in his keynote on Monday, which I'm guessing most of us went to, and he spoke about the areas of investments that we are working on to help you transform your data center or help you in your roadmap along private cloud computing or hybrid cloud computing, and so on. I'll take a minute to just sort of connect back networking to this frame, right? Now, if you take a step back for a moment and think about networking, all of us know that it's fundamental to data centers, right? Networking has been there, right? All of us are super familiar with it. A lot of us, I'm suspecting, spend a lot of time working with our networking counterparts, right, on a day-to-day basis from an operational standpoint. So a lot of us, in our minds, think that networking is a given, right? That's how it works, right? And we'll just play with it, while we are trying our best to sort of optimize compute, for example. What I'm going to say is that we are at a pivotal moment where there is an opportunity to rethink how networking gets done, right? And there's a lot of upside to sort of staying with me on that argument, right? If you think about it, it almost seems like all the stars are aligned. A lot of you folks are sort of figuring out what's the next step beyond virtualization, right? How do I think about my private cloud? How do I think about hybrid IT? Right? At the same time, we are delivering some fantastic technologies with Windows Server and System Center that help you shape networking as well, right? So it just seems like everything is coming together. You need to anyway think about your data center holistically, and all the piece parts or all the solutions are also coming to market alongside. So we feel pretty excited about it, and we really think that there's an opportunity to rethink how we do networking. And let's take a moment then to sort of understand what are the requirements around transforming networking, relative to how we know it today, right? So the first thing is, delivering networking as part of a pooled, automated infrastructure, right? What does that mean? By a show of hands, is it fair for me to assume that a lot of us are sort of server administrators or folks who care about the server infrastructure in our data centers? Okay, I see a lot of hands. I'm guessing that there are other folks who are interested in networking or who do work on networking as well. But the point here is, I'm guessing a lot of us have done a lot of work already in terms of advancing virtualization. In many cases, we've actually delivered the ROI of virtualization to our organizations through consolidation initiatives and the like, right? And in some cases, even progressing beyond virtualization to plan our cloud computing roadmaps and the like, right? At the same time, you might think that, gosh, live migration today, it seems super trivial, right, as a proposition, given all the work that you guys have done in terms of server virtualization and optimizing your data center in that context. But migrating the IP addresses of a server may not be always as trivial in that case, right, in sort of supporting live migration. Why is that the case? I think we think that networking historically has been, and even today, it's sort of thought about very monolithically. So you can think that you've got servers which are potentially optimized, but then you've got a bunch of physical cables that attach switches and routers and ports to that server. So networking, frankly, has not progressed at the pace at which data center computing or server virtualization has progressed, frankly. And we think that that's a little bit of a bottleneck. It is a no-brainer to make sure that you can think about networking holistically as part of your data center or infrastructure fabric. And we see a lot of opportunity for you folks to work with your networking counterparts to make that happen, right? So that's the first requirement to transform networking. The second piece is around multi-tenant isolation, scale, and performance. And I'm going to make a statement in the room that all of us are service providers of some sort, right? In some cases, we might literally be service providers. In other cases, all of us need to have a mentality of a service provider, right? So if you think of the premise of hybrid IT, it's predicated on the fact that you folks, as IT, can sort of step up and be that broker of IT services to your business stakeholders, right? You might be delivering those IT services in some case, or helping your business procure those IT services in other cases, right? But either way, you need to have that mentality of a service provider, and that's how you will gain the trust and a seat at the table with your business stakeholders, right? So in that context, if you ask yourself, do I have the capabilities to help deliver on that expectation of myself to be a service provider, right? Am I able to actually help my business units isolate their traffic depending on their specific needs? I was speaking to a person who was part of a legal firm at MMS, and he was telling me, gosh, we absolutely have requirements where our traffic and our files and our data need to be well segregated, even within other departments in my company, right? So are you able to do that? Are you sorry. I'll let it be there for a moment. I'll go up and fix that. But basically, another requirement is chargeback, right? So are you able to, as a service provider, assess what networking resources are consumed by which organization? And the answer is likely no, right? Another requirement is scale, right? A lot of us are familiar with primitive isolation mechanisms like VLANs, but then again, they don't scale beyond a certain point to help support your private cloud and hybrid cloud initiatives, right? And then there is the aspect of performance. And again, this relates to the fact that you can isolate and treat different types of traffic to a different quality of service as per your commitments to your stakeholders, right? If you think about how networking has been historically over the last many years, or the last 30 years or so with IP networking, the premise there was, let's have a standard and reliable mechanism to route traffic, irrespective of what kind of traffic it is, right? And we've still not seen enterprise organizations embrace the concept of traffic isolation based on policy, right? So again, these are all opportunities for you to work with your networking counterparts to sort of try and transform your data center. The third one is, expanding data center capacity, right? I can take a couple of quick examples here. One is, let's say your company actually acquired another company. Let's say you work with Contoso, and Contoso acquired Fourth Coffee, right? Now, you don't want Fourth Coffee to jump through hoops in trying to integrate their infrastructure into yours, right? You want to make it super easy for them to sort of incrementally integrate versus having to sort of, have a bunch of people working on that process. Conversely, if you as a company want to extend out your data center, given a certain expectation of spike in requirements at a certain time in the year, tax season now, for example, right? You want to make sure that, again, you can seamlessly extend into a third-party data center without having to sort of, again, jump through hoops, right? These are all basic expectations that a lot of companies will have as they think about hybrid cloud computing. So we want to make sure that that is met as well. We still see obstacles there, and there is opportunity here. The last one is, operational complexity, and this is almost like the final frontier. Even if you do those three things, we feel like network operations has lagged. So I'll take a quick example, right? From a process standpoint, I was speaking to Forrester, and they were telling me that a majority of organizations still use ticketing systems and emails and phone calls as the way to communicate moves, adds, and changes between the server and networking teams. I don't know if that's true broadly, but I was actually part of a team in enterprise IT that used to run network operations, and I knew that that was how the server and the networking teams would work together, right? There's a level of, response times which get delayed because of how the process works fundamentally. From a technology and, people standpoint, again, we see that the control plane, as we call it, has been sort of pretty proprietary in most cases, and we find that we find that all the work, be it configuration, be it provisioning, needs to happen one networking element at a time, one switch at a time, one port at a time, one router at a time, right? I was speaking to a customer here at MMS, and he was telling me, a medium-sized change in my network on an average requires me and my personnel to touch roughly 100 to 500 switches. And he said that, gosh, that takes away a lot of time from my people, and how they can sort of spend that time in doing much more valuable work for my company. So again, there is a great opportunity to sort of simplify operations, frankly. And a lot of you have an opportunity to shape how this might happen in collaboration with your networking counterparts. So with that said, we've sort of framed, what are the challenges and what opportunities do those challenges lead into. So with that context, I just wanted to sort of define or level set on how Microsoft thinks about SDN in the context of some of those opportunities that you just saw, right? So the first thing to note is that we think about SDN as a solution versus being a set of technologies. There's just a lot of buzz in the marketplace around, hey, is it about protocols? Is it about OpenFlow? Is it about controllers and so on? But we just think of it as being a solution, and there's a bunch of underlying technologies and processes and people that make it happen underneath, right? The second thing to understand is that we want to, again, pivot on the workloads or the applications, depending on what context to speak about them in. We want to pivot on workloads and the network being able to dynamically adapt to meet the needs of those workloads, right? And that's what your business stakeholders care about at the end of the day. With that said, let's unpack this a little bit more, right? What are the things that we think an SDN solution should accomplish? The first thing is around abstraction, right? And this, we believe, is where the real breakthrough in software-defined networking is. If you step back again for a moment and think about why did server virtualization take off, it took off basically because you certainly abstracted, virtual. You had an abstracted unit called virtual machines, which was abstracted from the underlying hardware. But that virtual machine retained the same properties of a server, right? A virtual machine had memory. A virtual machine had virtual CPU resources, and so on and so forth. So it was relatively easy for the operating systems and applications on top to understand those primitives and communicate to the VM. And it was super easy for us as IT pros to actually do exactly the same things to a VM as you would do to a server, right? You can provision workloads to that VM. You can snapshot that VM. You can roll back VM. You can update that VM or patch a VM, and so on and so forth, right? So it was relatively easy for us, us as IT pros and for the applications to grok the concept of a VM. And that's what made that server abstraction and server virtualization take off in such a dramatic fashion, right? Similarly, we have a concept, and we'll talk more about this, called virtual networks, which basically abstracts the physical network from the workloads on top, right? And by doing that, we also retain those same properties that you would associate with a physical network. You should think of virtual IP addresses, virtual switches, virtual port profiles, and what have you, which are super similar to how we understand physical networks. So the same arguments and the same things which led server virtualization to take off applies here as well. What's also interesting is that those virtual networks have the ability to associate themselves with a particular customer, or a tenant, as we call it, in a multi-tenant context. So you can sort of think about a customer's workloads and their network properties being aligned or being manipulated together. So for example, if that customer's workloads need to be migrated or instantiated, then you can actually have the virtual network attach themselves to that workload, and it can sort of offer a level of flexibility, which is unprecedented, again, in terms of how server virtualization and network virtualization work together, right? So this is where the real breakthrough is, in our opinion. And once you do that, you get this amazing flexibility as well to control data center traffic flow. You can actually ascribe a certain set of properties to virtual networks so that certain types of traffic can be prioritized over others with concepts like quality of service, right? You can also, in many ways, you can also think of this as sort of having a much more simplified way to control traffic flows in a centralized fashion, right? So this is what abstracting the network from the workloads enables, right? That ability to control data center traffic flow. And then finally, in our definition, we believe that there's a need to have integrated policies that actually span physical and virtual networks. So we want to make sure that there's a broader surface area of the data center than just talking about virtual networks that we want to cover or include in our definition. And we think that this definition is therefore broader than what a lot of other players might be actually talking about in the context of SDN. So a reasonable question to ask is, where did you come up, or what informed the definition and Microsoft's approach to SDN? And how did you guys sort of identify some of those challenges that you spoke about, right? So it turns out that the origins of our software-defined networking strategy lies in our experiences actually architecting, implementing, and designing networks for these globally scaled services like Windows Azure, like Bing, like Hotmail, and so on and so forth. So a lot of what you just saw are basically distillations of our experiences here, frankly. I can give you a few examples. Firstly, from a pooled networking infrastructure design perspective, what we found is that there's a lot of capital and operational efficiencies to be gained by actually thinking of networking as being sort of horizontal and serving multiple applications and services on top without having a silo mentality to designing networks, which is how it's historically worked in the past, and which is how it's in a lot of enterprise data centers as well, as per our opinion. So just sort of decoupling the applications and workloads from the physical and virtual networks underneath it helped us actually improve aggregate network capacity available to applications, as well as save a lot of money in how we actually operated those applications, operated the network. Another example is just the flexibility that was required with multi-tenant services like Windows Azure, right? It was a no-brainer requirement that customers told us, gosh, if you want us to onboard into Windows Azure, we need a simple way by which you guys can help us bring our own IPs to your data center, right? So it was, again, a no-brainer there. We absolutely needed ways to isolate traffic for a dev environment versus a staging environment versus a production environment. We absolutely needed to make sure that we have a level of isolation between the various enterprises and small and medium businesses which run on Windows Azure, right? And then with automation, right? You remember what Brad said at the keynote. He said, we roughly make 50,000 changes every day in Windows Azure on the network. And if you think about, that, we absolutely needed a level of automated configuration management around how do you manage and track changes. And we had to do it in a centralized and simplified manner, right? So these were some of the principles around designing networks for public clouds and for public cloud services like Windows Azure and Bing and so on. And that informed our SDN approach and what we built into Windows Server and System Center. So then, what were those principles then? So these, so then what is our fundamental promise with software-defined networking? It's basically, premised on the three areas: flexibility, control, and automation. Flexibility, like I mentioned, in the context of multi-tenant isolation, the ability to sort of abstract your workload from the underlying physical network. Control, in terms of having a centralized view into the physical and virtual networks and the ability to manage them in a simple and reliable fashion. And then automation, which makes sure that all of those traffic flows that you've sort of defined through virtual networks are implemented in a consistent manner and can scale as workloads keep migrating or getting instantiated in a flexible and dynamic manner in the data center. So those were the three promises, if you will. And then there are three, again, fundamental tenets or principles that we will use in our approach to SDN. So the first one is what we feel a level of responsibility in making sure that we deliver an end-to-end solution, right? This is not just about technology. It's about making sure that scenarios like hybrid cloud computing or private cloud computing are met, and that you can think about, that flexibility at your data center level or across multiple data centers. We want to make sure that that happens. The second piece is we are committed to promote innovation holistically across hardware and software. We believe that there is a place for hardware. I mean, we don't agree with a lot of proponents which say, hey, we think that the networking hardware is going to be commoditized. We think that there is a lot of value in making sure that we leverage the value of that hardware in things like performance, for example, right, and task offloading and so on and so forth that works in conjunction with our software. As an example of a commitment to promoting industry-level collaboration, you would have seen the announcement on Open Daylight, where we've taken on the platinum participation role in making sure that we contribute a level of IP to that effort and promote broad innovation across hardware and software. And then finally, we take an approach of being open, extensible, and standards-based. What that means is, partners can natively extend our platform. Partners can build appliances that, help connect physical and virtual networks based on standards, open standards like NVGRE that we support in our platform, right? So that's our promise. That's our principles. These are all governed by some of our learnings that we had in operating cloud scale services. So let's take a moment as well to talk about some of the excitement that we are seeing with Windows Server and System Center broadly, as well as in the context of network virtualization and SDN, before we actually get more deeper into the promises that I mentioned about earlier. The first thing is, there has just been a ton of innovation that we delivered, and we are seeing a lot of plaudits coming in from various industry sources. Certainly customers, who are leveraging some of those path-breaking innovations in storage and networking. We are seeing a lot of customers migrating from VMware to our platform. We are seeing a lot of industry analysts also talking about some of the innovations that we made in a very positive fashion. Specifically, you can see how Empire CLS is actually using the power of that flexibility in abstracting their physical network resources from their applications and workloads. You can also see how Forrester talks about the ROI that Windows Server offered and how network virtualization contributed to their benefits as well. So again, just a lot of positive press and momentum in our favor. So with that, I'm going to invite CJ to talk about the promises around flexibility and control and automation that are laid out.
Thanks, Anant. So what I want to do is kind of drill into some of the more, technical aspects, some of the features in the products that actually build out our entire SDN solution. So I want to use the same kind of three foundational promises that we think SDN brings. So the first, let's talk a little bit about flexibility, and from here I'll go into the kind of specific features. But when we think about flexibility, a lot of it, what we think about is around, like, let's say the virtual networks, right? So you have a physical network that's going to be fairly standard, right? You can't easily redeploy your top-of-rack switches or your core network and that sort of thing. But what we can do is we can abstract that physical network, and we can build these virtual networks on top of the physical network, and these virtual networks can go anywhere you want within your physical network. So you have the flexibility, especially from, let's say, a tenant perspective or an application perspective. You can build out your virtual network however you want, modify it over time, move it around, and it all just works without having to reconfigure and modify your physical network. Or from let's say a application perspective or a tenant perspective, they can bring their own IP address range. So you have the exact same physical hardware. On the physical network, you can't have things like overlapping IP addresses, and you can't have the same subnet for multiple applications and whatnot. But with virtual networking, you can actually, within your virtual network, you have complete freedom on what type of IP addresses, what kind of policies, what kind of subnet ranges, broadcast domains, and whatnot that you actually provide. And then, going back to, it can move around over time, and you're separated from the physical layer. And then, of course, the other thing is that you have the flexibility with the secure, cross-premise connectivity. You can move between, let's say, your on-premise site and the cloud, or you can move between multiple data centers in a secure fashion without having to reconfigure everything inside your network, because it's virtualized away from the physical fabric. And then when we think about control, a lot of what we think about is around, let's say, the virtual switch, right? Because now you have a software component that's sitting on every host, and I'll talk about more details when I get to it, or later in the slide. But you have a lot of ability to set policies, set how you want your applications to interact with the network, set things like bandwidth minimums and whatnot. And you can control this all from a centralized place, because you have these software components that are sitting throughout the network on every single host. And then the last thing, which ties together the flexibility and the control, is around automation, right? And this is really what SCVMM provides, right? Is how do I do it not on one machine, but how do I do it on 1,000 machines? And how do I do it with 10,000 VMs? And how, as I move a VM between multiple physical hosts, how do the policies just automatically move with it? Or how does the routing of the packets just automatically update as soon as I just hit the live migrate button? And hopefully Dinantha is working on getting the demo, making sure we can do it, and I'll show a demo later on. But it provides this capability where you do one thing in SCVMM, like live migrate, and then underneath the covers it reconfigures the network, the virtual network, and make sure that the physical side of things just work, transparent to the admin, transparent to the user. And really, when we look at this is a combination of features that are provided between Windows Server 2012 and System Center 2012 SP1. So let me drill in just a little bit on kind of the main pillars of what the SDN solution are. So first I'll talk about Hyper-V network virtualization, explain a little bit about what it is, how it works. Then I'll talk about the virtual switch and virtual switch extensions, and then I'll tie it all together by how they're managed through SCVMM. So the first on network virtualization, I'm sure there are a lot of server admins, so I'm sure everyone's very familiar with the concept of server virtualization, right? You have from the VM perspective, it's totally isolated. It's a version of the OS running. The application thinks it's the only thing running on that machine, but you can have multiple of these virtual machines sitting on a physical host, and that the isolation between them is secure. You can determine how much resources each one gets, but within those set of resources, that VM is in total control of how it actually uses those resources. And with network virtualization, you can think of it very much the same way, right? So you have a physical network. It has a set of capabilities. But what you want to do is you want to make the tenant, in this case, or the virtual network, think that it has complete control or complete access around that physical network while securely isolating between various virtual networks or tenants. And so that's kind of the conceptual view of Hyper-V network virtualization. And kind of drilling in one level deeper is there are a few kind of core concepts around network virtualization. So the first is this concept of a customer's VM network. And this is basically, your virtual network that the customer has. They can define the IP addresses within this virtual network. They can define, the policies that happen within this virtual network. And it's abstracted away so that they think they have complete control and that this looks like a physical network to them, right? To let's say the VM that's running on top of this, they have no idea that this is, a virtual network that's sitting on top of a physical network. They think they're just communicating like they've always done, right? And within this customer's VM network, they can define things. They can define virtual subnets, and these virtual subnets are just like physical subnets in that they're isolation boundaries for broadcast. Right, so if you have broadcast packets, you want to determine, let's say, where to send a particular packet. This isolates how far that broadcast actually goes, how many machines that actually goes to. And you can see that in this example, so you have one single physical fabric, which is this multi-tenant data center. And you have two corporations that are running on it, right? And they're securely isolated. They don't know that they're actually running on the same fabric. You have the red HR network. But you see the blue corporation has decided they want to further isolate, potentially for regulations or other reasons. They want to further isolate their networks. So you have both an R&D network and a sales network. And then within each of those networks, they can define these virtual subnets. So you can have multiple subnets within these customer VM networks. And that the customer can then decide, for instance, the blue corporation, they can decide what kind of traffic goes between these networks, right? So there's a concept of a gateway that would sit in between these, and they can determine policy of how and when packets would be able to flow through between these networks. And so they can create a lot of isolation, create a lot of kind of policy that determines how their network works. And then when you look at how kind of this concept of this overlay network or this virtual network works, the example here is, same two corporations. They have a set of machines. So both of them have Exchange servers, both of them have SQL servers, and they, because they're coming, let's say, from their physical network, they already have these defined IP addresses. And it happens that they overlap, right? They have the exact same IP addresses. It happens that both their Exchange servers have this, .5 address, and both of their SQL servers have this .7 address. And you can see in this example that they're actually running on the same host. So it's not just that they're running on the same physical network. They're actually running on the same host, right? And this is not something that on a physical network you could actually have, right? Because there would be collisions of IP addresses, and you wouldn't know how to, or the operating system wouldn't know where to send the actual packets. But in this case, what they do is they push to SCVMM this policy, right, that says, I want these two addresses. And then there's this concept of a provider address space, which is essentially the physical addresses, and then the customer address space. So while on the physical address space, or the provider address, you can't have overlapping IP addresses, right? The two hosts have different IP addresses. At the customer address level, within or between virtual networks, you can have any overlapping IP address combination that you want. Within the virtual network, you have to, maintain the same networking principles that you have today. But between these, they're completely isolated, so how they work is just fine. And it's actually SCVMM that pushes this policy out to the host. And so when you want to route packets between these, what happens is using what Ananth talked about was this NVGRE, or network virtualization using GRE, which is an industry standard for encapsulated packets. What happens is you have what's known as an outer packet, which is what goes across on the physical network, and you have an inner packet, which is what the actual VMs see, and that's the actual customer address space. And so from the physical layer, packets are just going back and forth, everything seems fine, and then it's actually the Hyper-V network virtualization filter that's running in the host that then decapsulates the packet, takes the inner packet, and then pushes up to the VM. And so from the VM's perspective, they have this .5 address and this .7 address, even though the underlying infrastructure never sees these addresses. So it's kind of a high-level overview of how Hyper-V network virtualization works. So then moving on to the virtual switch. I'm assuming most people are familiar with the Hyper-V virtual switch. Show of hands, most people understand what it does. But from a high level, the Hyper-V switch is what sits within the physical host and translates or is the communication channel between the virtual machines and the rest of the infrastructure, right? So any packets that's going between VMs, going from VMs to a physical machine, or going from a VM to an external network like the internet, all go through this virtual switch. And so everything that the VM, or anytime the VM communicates, it communicates through this virtual switch. And so it gives you a central control point on a single machine to actually manage how the traffic flows. What kind of bandwidth is given, what kind of policies are provided or are enforced on the network or on the VM. And so when you look at what was built in 2012, it's a broad range of features in the virtual switch across a number of aspects, right? So you have tenant isolation, right? Even different from network virtualization, but actually tenant isolation on the physical network can be provided. And so you have things like port ACLs. You have things like private VLANs. You have things like trunk mode, where you can trunk multiple VLANs into a specific port. From traffic shaping, you have QoS, you have bandwidth minimums and bandwidth guarantees. From performance, you have dynamic VMQ, which allows essentially the VMs to use more of the underlying CPU cores for processing the packets. For security, you have things like DHCP guard that prevents rogue DHCP servers from coming onto the network. You have router guards, same thing, prevent rogue routers from or rogue VMs from acting as routers on the physical network. And then IPsec, which is a fairly prevalent security technology on how you encrypt the packets. We support task offload so that if the underlying physical NIC provides, what would I say? Sorry, I lost the word. Would provide is speed up and hardware acceleration in the physical NIC, we can actually, the VM itself can use that acceleration directly. And so you don't have, you no longer have kind of a VM having less performance than the physical host would have around IPsec. And then from diagnostics, You have the capability of mirroring ports, so if you want to be able to take a port and run it through a diagnostics application or look at what traffic's going on at a particular port, you can use port mirroring. We also have ETW tracing and unified tracing. But then the question is, so we delivered a lot of capabilities, but what happens when you want, a partner wants to extend the virtual switch, or you want to add additional capabilities onto the virtual switch? We added the capability of extending the virtual switch, right? So no longer, in some cases, people would want to replace the virtual switch, or if they wanted to provide additional capabilities, or they had no good way to plug into the virtual switch. And so in 2012, what we did was we opened up the virtual switch to third parties that they can actually build extensions that modify how the virtual switch works. And so there's different categories of switch extensions. And so, the first one is you want to be able to capture packets. So this might be for monitoring, it might be for billing. There's a number of reasons why you'd want to be able to capture a packet and send data, like how many packets of a certain type did a VM send, or how many packets did a VM send to a particular IP address. And so all of this can be done in the capture extension. And then you have the filtering extension, and kind of the prototypical application for this would be firewalls or intrusion detection. And so third parties can leverage this capability by extending their firewalls that might be let's say a hardware appliance or something else, all the way down into the virtual switch. And so they can control how the virtual switch filters packets based off of rules that are coming from, their application. And then you have, and in both of these cases, you can actually have multiple of these extensions running at one time. And so you might have extensions from different third parties, one doing firewalls, one doing intrusion detection or something like that. And then this third type of extension is called a forwarding extension, and this actually modifies how the virtual switch forwards the packets, right? And so the prototypical examples of these are NEC built an OpenFlow forwarding extension that builds out OpenFlow capabilities directly into the virtual switch. So even though Microsoft didn't build in-box OpenFlow capabilities into the virtual switch, NEC came and built an OpenFlow extension that then works with their OpenFlow controller. And then also Cisco built their 1000 kV switch extension that does similar thing, is that it integrates the virtual switch into their overall physical switch management. And so now you have one management plane across both the virtual switch and the physical switch. And so when you look at the benefits that the switch extension provides, I'll just talk through a couple of these, not all of them. So the biggest one that we see is that it's an open platform, right? So third parties can bring their innovation, their enhancements into the virtual switch without having to completely replace the capabilities of the virtual switch. And one of the big things that we did as part of this, as part of these switch extensions, are that all the core services that the virtual switch provides continue to be provided in addition to the capabilities that the switch extensions provide. So all the performance, all the kind of the basic, let's say, forwarding if you don't have a forwarding extension, or all the basic monitoring capabilities are all there. They're just enhanced by any extensions that get installed. And then the other thing is that we have a logo program around these switch extensions. And so there's a level of guarantee that the reliability and performance of these switch extensions when they get installed won't modify kind of the base capabilities of the switch extensions when you look at how reliable it is or how performant it is. And then the other thing is there was a lot of work done around diagnostics and this unified tracing that I talked about. And so switch extensions, when they get installed, automatically work within this unified tracing mechanism. And so, when problems do arise, when, let's say, packets get dropped, an admin can actually use this unified tracing, whether there's switch extensions installed or not, to determine what happened there. And in some cases, let's say you have a filtering switch extension, it might be doing its job by filtering out a bad packet, but you can use this unified tracing mechanism to understand what is actually causing, let's say, packet drop or something like that. So that's the switch extensions. And so when you look at Hyper-V network virtualization and the virtual switch and the switch extensions, that's all capabilities that are built into Windows Server. And so all of these are manageable by, let's say, PowerShell and kind of the standard base management capabilities of Windows. But when you want to do this not on one machine or two machines, but you want to do this on 1,000 machines, you need a level of automation and a level of capabilities that while are leveraging the underlying management capabilities, you need something that's set on top of it. And so this is where SCVMM comes into the picture and provides that level of automation that you don't get through the base kind of management capabilities. And so I wanted to talk through a couple of new concepts that came in SCVMM 2012. So the first one is this notion of a logical network. So the logical network basically brings in your physical network into SCVMM so that it knows how the physical network is laid out. And this is how, essentially when you think about something like a virtual network, while they're decoupled from the physical network underneath, there needs to be some interaction between them. And so this concept of the logical network that's brought into SCVMM provides this knowledge of what's happening in the physical fabric so that things like the virtual networks can be built on top of them and can be abstracted away so that while the tenant that's running in that VM network doesn't know about what's happening on the physical fabric, the actual admin does know about what's happening on both the physical fabric and the virtual fabric. And then also, SCVMM is used to manage the virtual switches. And so all the policy, all the configuration that's pushed out to the virtual switch, including things like the switch extensions, are all managed by SCVMM. So you have a virtual switch template that you want to provide, and you want to say every VM or this particular VM needs, these 2 or 3 switch extensions and needs these policies and needs these configuration settings. And so SCVMM, when it actually deploys that the VM will automatically go out and push that configuration down into the virtual switch. And then when that VM is moved onto different physical hosts, all those configuration policies, all those switch extensions, all those policies are moved with it and configured into the other host. And so you don't have to worry about, let's say when you go live migrate, you don't first have to worry about, manually moving all the policies or seeing does that physical host actually have the policies or the switch extensions installed that I need. SCVMM will automatically do that as part of that migration process. And then the next thing that I want to talk about is a new concept that came out, which is this notion of a logical switch. And so, you have this ability on each host to have a virtual switch. But what happens when you want to say across a large number of physical hosts, you want all the virtual switches to act and look identical, right? And this is where the logical switch comes up. And it's kind of a step above the automation of when a VM migrates, the new policies are pushed out to the host. This ensures that for a set of virtual switches, that you can configure that all the policies stay intact, all the policies are identical, all the switch extensions that you want installed are installed by default, and that they look from let's say a VM perspective that they're all identical. It's just one big logical switch that's distributed across a large number of machines. And so when you look at what SP1 provided for 2012, is it really provided the management layer and some of the control layer for managing the SDN solution, right? So you can configure your virtual switch. You can configure the logical network underneath. You can configure the virtual switch and all the policies and capabilities that it provides. And when you look at kind of how all the pieces align, it's the thing that makes sure that everything runs smoothly, everything runs at the scale of 1,000 machines, and that everything is configured properly, and that all the policies and all the capabilities of the virtual switch or the virtual networking is pushed across all the machines that it needs to be. So what I want to do, and hopefully we have this working now, what I want to do is walk through the same demo that VJ did on the keynote, but I want to provide a little bit more color, a little bit more detail on what's happening and tie it into these other pieces. So if we can switch over, hopefully this works. Okay, great. What this is showing is you have this Contoso Corporation, right? And they bought this Fourth Cup coffee company. And a lot of times when in this example, when you have companies that are coming together, they'll have line of business applications, they'll have, other things that are configured, especially within the network. And a lot of times, a SQL Server or a line of business application will be fairly tightly coupled with, let's say its IP address. So it's not easy to go in and modify all the IP addresses that these applications require, that the applications are expecting the SQL Server to use. And so when you want to, let's say, collapse these applications or these two companies' applications on the same physical network, that's where something like Hyper-V network virtualization really provides the capability to do this. Because then, in this case, as you're migrating on the same physical network, you can actually provide that isolation so that they can continue to keep all the configuration that they're expecting. And so in this case, you have Contoso that has this sales application, and they have a couple instances of these running, and they have specific IP addresses. But what they want to do is they want to migrate from this New Jersey data center to the New York data center. And in this case, they're fairly closely aligned, and so they have a lot of bandwidth between them. They have a lot of connectivity, and so you're managing both these data centers through the same SCVMM instance, but you want to be able to move the workloads between these data centers. And in this case, while you have connectivity, the physical fabric is different subnets, right? Which without 2012 and Hyper-V network virtualization, you couldn't actually live migrate between, let's say, different subnets on the physical layer. But in this case, all of it is taken care of by network virtualization. And so what I'll do here is I'll just drag this 7 application over to the New York data center. And this is where the Fourth Cup coffee application is also running. So I should have dragged it earlier. So while it's initializing, so what it's happening is this 07 application and the Fourth Cup coffee application have the same IP address in the customer space, right? And so with network virtualization, you can have this overlapping IP address ranges on the same physical machine, because of the network virtualization is actually isolating them and doing this encapsulation that allows you to have the different the underlying physical infrastructure not know about these overlapping IP addresses in the customer space. So let's kick off this migration. Nice. Be a failure. Maybe it worked. Okay, so I'm not sure what happened there, but looks like it's working. So if we go over to the application that's actually showing what's happening, is you have this Contoso application that's talking to your physical fabric, right? And so the physical fabric, even though these sales applications are in your virtual network, it can still communicate with, let's say, a SQL server that's running on the physical fabric. What you need is this what we call virtual to physical gateway, right? And there were some announcements by partners that are building these virtual to physical gateways. But when you live migrate, the connection is still happening. You're still getting traffic between them. You can still, a customer can come in and still use this sales application, and it all keeps working, even though you're moving it between physical networks, right? And then when you look at it, now that it's migrated over to the New York site, that even though they have the same 10.10.20.9 IP address, this Fourth Cup coffee and this Contoso sales application, they're running in different virtual networks, and so they can continue to run, continue to function, continue to have traffic sent to them, even though they have these overlapping IP addresses. And so, when you look at this, the two main things to get out of it is that now you can migrate your virtual machines regardless of what the underlying physical fabric is. So you don't have to modify VLANs. You don't have to make sure you're only migrating it within the same physical subnet. You can migrate it regardless of what the underlying physical network looks like. And then when you have applications, that have hard dependencies on what they think the network looks like, you can use this network virtualization to abstract away the physical network. So you don't have to reconfigure your applications, and you can securely isolate them, and you can isolate, let's say, the IP addresses, so you can have multiple networks that have overlapping IP addresses running on the same physical network. So now I'll bring up Dhananjay to talk a bit more about the partner aspects of our SDN solution.
Thanks, CJ. Hi, everyone. Partners are an important part of our ecosystem. And I'm Dhananjay Mahajan. I'm a senior program manager on the partner and customer ecosystem team. And I'm excited to talk to you about how SDN is a platform that's open, extensible, and standards-based. And partners are an important part of our ecosystem because we know customers like you have other network devices in deployment, and you don't want to have a system that doesn't work with it, doesn't interoperate with it. In fact, you want a system, a software, a platform that can show more of the value of the solutions that you have or the devices that you have in your data center. SDN, the Microsoft SDN platform is pluggable. With VMM, you get pluggable interfaces. We have a gateway plugin. We have a load balancer plugin. And it allows partners to connect with VMM so that customers like you can use VMM as the console to manage your network. Deliver load balancers, deliver site-to-site VPNs. It's a fully integrated experience. And when you think about your data center, we don't think about SDN as Anand said, as having dumb switches. We want you to have better integration between your hardware and software layer. And that's provided by the extensibility that we allow in our platform for partners to plug in and come up with their differentiated value. CJ went into great amount of detail about Hyper-V virtual switch extensions. And the Hyper-V switch extensions are being used by several of our partners to extend the SDN policies. Now, not only one, but multiple of these switch extensions can coexist together, so you get a comprehensive solution. So we have some of our partners like Inmon who have traffic monitoring solutions. There are control flow solutions with switch extensions that have been incorporated. And we actually take partners along our way. When we design SDN as a platform, we come up with best practices guidance that we share with our partners. We give them testing tools. We bring them to plug fests. We give them advanced knowledge of how to use our platform. And that is evident from the fact that we are going with a standards-based approach. With a standards-based approach, as Brad pointed out in the keynote, we have just announced Open Daylight Foundation, and we are one of the partners that are part of it, driving the Open Daylight Foundation. We've also built on standard protocols such as the IETF Generic Routing Protocol, or GRE, and CJ went into great detail about NVGRE. So standards-based support gives you much more flexibility, much more choice as switches, top-of-rack switches, ASICs, NIC vendors are bringing these in the coming days. So we have a large partner ecosystem. We talked about NEC, which has an open flow controller, which they have integrated with us and is available to customers with a PF1000, so that NEC manages the control flow and VMM decides which are the source and destination VMs, and then works through the OpenFlow vSwitch extension to make sure communication and connections are happening between the source and destination VMs. We have Iron Networks, who has built a complete IaaS, an iron point solution which is available on the Explore floor for you to see as a complete entire stack for IaaS, where the NVGRE gateway is a key component of it. So if you're looking for adopting this platform, you have a solution that's out there. And then we also are working with Cisco. Cisco announced, as CJ mentioned, support in the 1000 vSwitch extension. And we are also continuing to work with several other partners like Broadcom, F5. So you'll see more and more announcements coming through. Do come back at TechEd, and you'll see more of this ecosystem developing. So what would we like to do? SDN is real. For Microsoft, it is a strategic bet that we are going after. And we want you to deploy Windows Server and System Center 2012 SP1 today and get the benefits of what some of our customers have already started reaping. There's more information available on these. And to summarize, SDN has the promise of automation, control, flexibility of the network. We're not saying that the switches become dumb, but we are actually saying you can realize more out of your hardware and software assets with the approach we are taking to SDN. And Microsoft has a unique value prop which gives you the choice with the partner ecosystem. Microsoft provides an open, extensible, standards-based SDN solution approach where you can not only use the best-of-breed Microsoft applications running on the Microsoft platform with our hypervisor and an ecosystem of solutions that you have. And we'll continue to bring on more innovation. As you have seen, we work very closely at Microsoft with Anand from the marketing team who helps us make sure SDN is properly positioned, and also with our field teams on how SDN is an important play. CJ's team, which actually is building the core technology, that's part of it, and me from the marketing, from the partner team, where we have a whole bunch of partner PMs who are working with the partners to help bring the ecosystem along. So we want to hear from you. We believe we have a compelling solution with SDN, Windows Server with Windows Server 2012 and System Center 2012 SP1. Please give us feedback. We would love to hear from you. And do come back at TechEd, and we'll have more to present at TechEd. So with that, thank you very much. Thanks for coming. And we are around here for Q&A. If you have any questions, we'll be available.